All right, so today, before we sort of wrap up this story that is polynomials and graphing, I think you've been reading or listening a lot to things like an x-intercept or a zero, like what are those things? Hopefully engaging in factoring and remembering how to factor, but also like what it means when we're factoring. And so before we sort of wrap up the story that is polynomials, we're going to learn one last skill right now, which is dividing polynomials, okay? And so it's one of those situations where we have a lot of different ways of solving problems. And this is just one more tool that we want to add to this idea of how we factor things and what happens when we can't factor them. How do we approach that? Okay. So let's start right here with what we know. All right, we've got our f of x equals x cubed plus 4x squared minus 12x. And I claim that this expression is factorable, and factorable in ways that we already know how to do. So what might be a first step in looking at factoring this, because this is like a x cubed, right? We don't normally factor x cubed. We normally factor like x squared. So what are some ideas we might have around this x cubed piece and how we take care of that? All right, so I see that Dallas says factor out the x first, right? And that would be something that maybe we notice, like this has an x. And instead of getting scared and being like, oh, x cubed, I don't know how to do that, let's just kind of keep going and see what else pops up, right? We have 4x squared. We have a 12x. And since every single term contains an x, right? We've got x, got an x, we've got an x, we can actually factor that out. We'll get x and parentheses. And what is left is x squared plus 4x minus 12. And if we were to describe this process right here, we might call this using the greatest common factor, or GCF, that greatest common factor, to help us get started. Now, we've got x and a quadratic now, x squared plus 4x minus 12. And so take a moment in the privacy of your learning environment and see if you can't figure out how to break x squared plus 4x minus 12, that trinomial, into two binomials. In other words, how do we factor that x squared plus 4x minus 12? Okay, so I see a 6 and a 2, and I'm wondering, I think those numbers are in the right ballpark, and I'm wondering if we could write them as like their factors. So I don't want a solution for x. I don't want what x equals. That's not what we're looking for yet. Okay, what we're looking for is rather like a factor, like x plus a number, or x minus a number, something like that. Okay, so when we factor, we want to make sure we have it in those parentheses sort of situations. Let's see what those factors might be. All right, let's see. So x minus 2, x plus 6. All right, if I were to do a quick mental refoil here, I would get x squared plus 6x minus 2x minus 12. Yeah, I think that works, right? Because the 6x and the minus 2x, that gives me that 4x. All right. So I know sometimes students are like, well, I'm not sure if I factored correctly, but here's the really good thing. You can take whatever you think the factors are, and if you multiply them back out, you should get what you started with. Okay. Now, I do want to add a sort of term here for us to think about. So if we write f of x as x times x minus 2 times x plus 6, right? So we write it as all the factors. Is x a linear term or a quadratic term? Yeah, x is a linear term. Okay, what about x minus 2? Do we think that's a linear term or a quadratic term or even higher power? X without a power would be linear, yeah. And I would argue there's a power there, we just don't write it. Right, what is the power in fact? When I have x minus 2, what's the power for x?
The power of 1.
Yeah, it would be a power of 1, exactly. Okay, so then if we have x to the power of 1 minus 2, that maybe makes it a little bit more clear that it's linear, right? And what would we say about x plus 6? Is that linear, quadratic, cubic? Exactly, and I love that reasoning, Ellie, right? It's still x to the first power, so it's still linear. And so what we have here is we have a clump of linear factors, right? Every single one of these are linear. And so the name we give this, if we can get something all the way down to linear factors, we call it linear factorization. Okay. Now, why is this important? This is important because let's say someone walks up to you on the street and they're like, is this a linear factorization or not? Right? They tell you, they're like, f of x equals x times x minus 2 times x plus 6. Is this a linear factorization? You would say yes, because this x is to the first power, this x is to the first power, this x is to the first power. Okay. We're going to be using this vocabulary quite a bit, so I just want to make sure that it's something that we're keeping in the forefront of our minds, that these fancy math names are important to learn because they help us access the content that we have. Okay. All right, so what's new? All right, what's new? We're looking at this f of x, a different one, which equals x cubed minus 6x squared minus x plus 30. And one thing that we might notice is that this one, unlike the other one, this has no greatest common factor. Okay. And the degree, what's the degree of this polynomial? Yeah, the degree of the polynomial is 3. And so these two things, there's no greatest common factor and the degree of f of x is 3, are really good hints. So these clues tell us to try division. Okay. And so if we sort of look at these two side by side, we had one case where we did have a greatest common factor. If there's a greatest common factor, go with it. Take that greatest common factor out, factor out the whatever is left to get to your linear factorization. However, what we're going to learn in this section right here is what do we do when there's no greatest common factor and the degree is higher than 3? We're going to want to think to ourselves, let's try that division thing. Okay. We're going to take a look at two types of division today, and they're both important for different reasons. Okay. So in particular, we're going to look at long division and synthetic division. All right. We're looking at long division and synthetic division. if anyone in this space is secretly or not so secretly thinking, oh, I might want to be a math major. I know that's kind of crazy, right? But if you're like, I might actually want to be a math major, this math thing is pretty cool, I will tell you a few things. One, people will be impressed by a math degree. Not that you should do it for other people, but it is sort of something that shows, oh, I can do these things, right? But the more direct thing is, if you are looking to be potentially a math major, long division actually comes up again in the upper level math. Okay. Now, if you are sitting here being like, I have so many other passions in life and math is really more of a tool for me, then synthetic division is likely a better tool for non-math majors, all right? So just kind of thinking about it in that way. But I want to spend some time today connecting the two, making sure that we know, okay, we have this long division format, we have the synthetic division. I will be totally fine if you want to do synthetic division, but I also want to put it out there that if you are considering taking some upper level math classes, that long division is something that will come up again. And so it might be important to learn if that's your path, okay? All right, so let's take a look at this long division situation, all right? So we're going to start with this question, number one. Is 2 a factor of 45? Right? So take a moment and think about that. Is 2 a factor of 45? When you have your answer, if you could send me a direct message, a yes or no is all I need. All right, so is 2 a factor of 45? Yes or no? Send that to me via a direct message. All right, I've heard from about half of you. This is good. Give you maybe about another 30 seconds. All right. So the general consensus for us has been no. All right, no, that it is not a factor, and that would be accurate. No, it is not. But let's sort of unpack why that is, right? And so one thing we might think of is 2 a factor of 45 is really saying, does 45 divided by 2 equal a whole number? Right? Maybe that's a different way to frame it. Does 45 divided by 2 equal a whole number? Or is there a remainder? Right? So we're sort of asking ourselves those two questions. Does 45 divided by 2 equal a whole number? Or is there a remainder? Okay. And so let's just sort of review this idea of long division over here. So if I wanted to say 45 divided by 2, I would make this like little symbol, which hopefully we've seen. What number goes underneath this little symbol? Yeah, we're going to put a 45 in here. And that means that the 2, where's that 2 going to go? We sort of have a few places to potentially put that 2, maybe to the left, maybe above. Yeah, outside on the left. Good. So we have a 2 here. All right. So how does this work? So we say we want to see if 2 goes into 4, right? We want to see if 2 goes into 4. And I would say, even though it's almost 10 o'clock on a Wednesday morning, we would all agree that 2 does go into 4. And in particular, it goes into 2 times, so we put a 2 up here. And then we're going to take this top number, we're going to multiply it by the number out here. That's going to give us 4, and we write that below the 4. Right? What do we do now? Before we bring the 5 down, what do we do? Yeah, we're going to subtract, right? So I'm going to put a subtraction here and draw that line. So 4 minus 4 gives me 0. And now I'm going to bring down that 5. Okay. Okay. Now what do we do? All right. So I think what you mean by that is, does 2 go into 5? But if we want to say if 2 goes into 5, we're going to do 5 divided 2, like that way. Yeah. So how many times does 2 go into 5? Well, it goes 2 times. So I'm going to put a 2 up here. And then I'm going to sort of repeat the same process. So this 2 times this 2 is going to give me 4. But now I'm going to put a 4 right underneath that 5. Right? We're going to subtract 5 minus 4 gives us 1. What this tells us is the following. Okay. So let's generalize this structure. We have the same symbol. The number we put inside there, that 45, the fancy word for that is dividend. So the dividend is this 45. The little number we put on the outside, that 2, is called a divisor. So this out here, our divisor in this case would be 2. Now the number at the top, this 22, right? That also has a special name. That is called the quotient. Right? So we've got a dividend, a divisor, a quotient. You go through this process however many times, and if you get a number at the bottom, right? We get a 1 here. What do we call that one? That might be actually the most familiar of all these vocab terms here. Yeah, that one is like a leftover, or in mathematics, we call that a remainder. All right, so this down here means we have a remainder, right? So you folks were correct. Is 2 a factor of 45? No, it's not. And in fact, we could say, no, it's not, because there is a remainder. And so what I'd like to do is write a sentence right here. So maybe we shrink this down. Oh, nope. Maybe we shrink this down just a little bit. And the sentence that I'd like us to write for ourselves is this. If there is a remainder, then the divisor is not a factor of the dividend. Okay. give you a moment to write that down, but as you're writing that, I'm going to color code the sentence to match the color coding that we did here. So if we find that there is a remainder, then the divisor is not a factor of the dividend. All right. So if there's a remainder, then the dividend or then the divisor is not a factor of the dividend. All right. So let's try going over this process of the long division again to see, is 5 a factor of 45? All right. Now, what's your gut tell you? Is 5 a factor of 45? Let's do a quick yes or no, just right into the general chat. Yeah, is 5 a factor of 45? I see general consensus coming up as yes, it is. Okay. And so in particular, we're thinking, is there going to be a remainder or not? Right? But let's practice this long division situation. We're going to set up a little symbol underneath. We're going to put the 45, but now our divisor is not going to be a 2 on the outside, it's going to be a 5. All right, so we've got our dividend, we've got our divisor, and our goal is to figure out, yes, what the quotient is, but in particular, is there going to be a remainder at the bottom? All right, so what number do I put right here above the 4? Yeah, we're going to put a 0 right there, right? And notably, we're going to put a 0 because 5 does not go into 4, right? So then we have 0 times 5, which gives me 0. We're going to subtract. We get a 4. We bring down the 5. All right. Well, does 5 go into 45? Yeah, 9. Okay, so I'm going to put a 9 up here. 9 times 5 is 45. I subtract and I'll get 0. So we've got 0 right here. All right. We're going to use this structure of long division to practice with polynomials. All right, so we're looking at not just regular number division, but polynomial long division. But before we get there, in this in general place, here's what I want us to write. All right. If the remainder is 0, then the divisor is a factor of the dividend. Right? So we're modifying our statement from above. Before we said if there's a remainder, then the divisor is not a factor. But now we're saying if that remainder is a very specific number, in fact, if it's 0, then it turns out that the divisor is not or is a factor of that dividend. All right, so that remainder, that thing that we get at the end actually tells us quite a bit of information. All right. So with that being said, we're going to walk through one example of polynomial long division. Okay. Again, this is perhaps the less important one for those of us who are saying, we enjoy math, we know we can do it, but it might not be our major in the future, right? But for those of us who are considering maybe some of those higher level math classes, long division will definitely come up again, okay? All right, so let's take a look at example 3. It says, is 3x minus 2 a factor of 6x cubed plus 11x squared minus 3x or 31x plus 15? Now, this question is a lot harder to eyeball, right? We can't look at it and be like, oh yeah, 9 times 5 gives us 45, so we're all good to go, right? But we can use the same structure. And so of these two polynomials, which one of these is the dividend, like the yellow one, the one on the inside of that symbol? Which one of these is the dividend? And you can just say the first one or the second one. Yeah, this one is like our 45, okay? This is our dividend. What is our divisor in this case? The first one. Yeah, so this 3x minus 2 is our divisor. And so we're going to set this up the same way that we did the other one. And we're going to say, at the end, we want to see what that bottom number is. Right? If it's 0, then yes, it's a factor. But if that bottom number or that remainder is not 0, then it's not going to be a factor. Okay. So we're going to leave ourselves some room. Got 6x cubed plus 11x squared minus 31x plus 15. And on the outside, I have my 3x minus 2. All right. So we're going to start very similarly. We're going to take things piece by piece. We're going to ask ourselves, 3x times what gives me 6x cubed? Okay, so 3x times what gives us 6x cubed? And I see that Jesus has already said that it's 2x squared, and I would agree that if we take 3x and we multiply it by 2x squared, we'll get 6x cubed. Now, where we put this 2x squared is really important, okay? We don't want to put it on top of the x cubed term. We actually want to line it up with the x squared term. So that 2x squared, I'm going to put right on top of the 11x squared, okay? And now we're going to take this 2x squared and we're going to multiply it by 3x minus 2. So we're going to get 6x cubed. And what's the second term going to be over here? Good, we've got a 4x squared, and in particular, it's going to be negative 4x squared. Good, okay. Now, what do we do here? We subtract, okay. Now I'm going to make a real big deal out of this. I want us to remember we are subtracting this entire thing, okay? And it's so important that we're subtracting everything that I will put parentheses around it every single time to make sure that I don't mix that up. All right, now let's subtract. What do we get when we subtract these two? Good, we get 0. And what do we get when we subtract these two? And be really careful here. Yeah, 15. All right, I buy the 15x squared, right? Because we have 11x squared minus a negative 4x squared plus 15x squared. Okay. All right, now we're going to bring down that negative 31. Now we're going to ask ourselves a similar question. 3x times what gives you 15x squared? 5x. And I'm going to put that above the 31x. Now we're going to multiply that out. So we get 5x times 3x. That's going to give us 15x squared. And then 5x times -2 gives me -10x. I want to subtract the whole thing. So I put parentheses around that. 15x squared minus 15x squared gives me 0. What do I get for the second term? 21x would be incorrect. Negative 21x. Okay, yep. We've got a negative 31x minus a negative 10x, which gives us negative 21x. Good. All right. We're almost in our last step. We're going to bring down that 15. We're going to play this game one more time. 3x times what gives me negative 21x? And I believe we'll see a -7, right? Then we'll get negative 21x plus 14. I want to subtract the whole thing. What do I get here?
1.
Yeah, we get 1. 1 is our remainder. So go back to this question. Is 3x minus 2 a factor of 6x cubed plus 11x squared minus 31x plus 15? It is not a factor. Good. So let's write that out, okay? So 3x minus 2 is not a factor of 6x cubed plus 11x squared minus 31x plus 15, since the remainder is 1. All right. So 3x minus 2 is not a factor. And the way we knew that is we used long division to see if there was a remainder or not. Okay. All right. So like I said, long division is one way that we can do this. The other way that sometimes students find a little bit easier to look at because there's not as many like X's in here is something called synthetic division, okay? And so let's go ahead and look at another way that I can ask this same question, okay? And I'm intentionally layering on the language here. I want us to be able to read these sort of complicated looking words and make sure we know what they mean. Okay, so the question is 3x minus 2 a factor of 6x cubed plus 11x squared minus 31x plus 15? We already know that answer is no. But look at this next part. If it is a factor, indicate the factorization. Right? If it is not a factor, specify the quotient and the remainder. We'll use this problem to practice what it means to specify a quotient and remainder, okay? And we'll use some other examples to practice indicating the factorization. But here's how we're going to set up our synthetic division, right? Some of you might have seen this before, but instead of using that long division symbol, we actually use a little like part of a square looking thing, okay? And there's going to be a number that goes inside here. And in particular, this number is going to come from our divisor, all right? And then we're going to write out some numbers over here that are going to correspond to the dividend, okay? But the nice thing about this is we strip away a lot of the letters. We don't really have as many like x cubed, x squared, things like that to worry about, okay? So let's start with what goes inside where this red is, okay? So here's what goes inside there. We're gonna take our dividend and we're going to set it equal to 0. Right, so 3x minus 2 equals 0. And I want you to do that, work it out in the privacy of your own learning environment and tell me what x equals. Good, I see a 2/3 in there. So we would add 2 to both sides and we would divide by 3 and we would get 2/3. All right. This number is what's going to go in that red shaded box. Okay. Now we're going to look at our dividend and we're going to pick only the numbers and their sign. And we get this 6, leave a little space, 11, leave a little space, -31, leave a little space, 15. In fact, we might say that these are the coefficients of our dividend. We're going to skip a line and then we're going to draw a line. Okay. So if you have a lined piece of paper, you're going to skip a line, then you're going to draw a line. All right, so here's how this process works, okay? The first thing we're gonna do, this first yellow number, we're gonna drop it straight down. Okay, first yellow number comes straight down. Then we're going to take the number here, all right? And we're going to multiply it times the 6. So 2/3 times 6, 3 times 6. What does that give us? Yeah, that gives us a 4. And we're going to write that 4 right underneath the 11. Okay, that's one cycle. We're going to keep going until we get to the very end. All right. 11 and the 4. We are going to add them. 11 plus 4 gives me 15. And then we're going to take this number, 2/3 times the 15. 2/3 times 15 equals 10, exactly. And that 10 is going to go right under that -31. All right. What operation do we do to combine the -31 and the 10? That would be not quite correct. That is the other option, okay? Now, I want to make a point about this because when we do regular division, long division, we subtract. But in synthetic division, we add, okay? So -31 plus 10 will give me -21. What do I do with that -21? we're going to times by that 2/3 exactly. All right, so 2/3 times -21 gives me a -14. I'm going to go ahead and add again as I go down the row. So 15 plus -14 gives me a 1. Now I'm going to zoom in for a moment. And some of these numbers should actually look pretty familiar. Okay. At some point, I see a 14, I see a 14, I see a 10, I see a 10, I see a 4, I see a 4. Okay. This 1 on the end that's our remainder. That very last number is our remainder, right? Since we have a remainder, of 1, 3x minus 2 is not a factor of 6x cubed plus 11x squared minus 31x plus 15. All right, so that's part of the question, right? Is it a factor or not? We said no, it is not, and we gave a reason. But we do want to read the question carefully, okay? And this was something that I think for some of us on the exam, we didn't follow all the directions, and so we didn't actually get to all the possible points for that particular question, okay? So as you're looking at the question, make sure you read and answer all of the parts, right? So it is not a factor, so we don't have to worry about the factorization. However, what we do need to do is specify the quotient and the remainder. So we know what the remainder is. We now have to find the quotient. All right. So we're going to go back in and take a look at what these numbers mean right here. This -21 is going to be a constant term, like it's just a number. This negative or this positive 15 is going to stand for 15x, like a linear term. What is the 6 going to stand for? Any guesses? There's a leading coefficient, but what degree? Like we have a constant, we have a linear. What's this one going to be? Yes, and what do we call that? 6x squared. Call that quadratic. Good. All right. What if I had another number in front of the 6? What degree would that number represent?
Cubic.
It would be cubic. Exactly. Okay, so we're going to start with our remainder, and then all of these numbers as we work our way out is going to tell us about a coefficient for a constant term, a linear, a quadratic, a cubic, and we just kind of keep going until there's no more numbers. But what that means is that 6, 15, and -21 really stand for 6x squared plus 15x minus 21, right? This is why it's called synthetic division, because we sort of hide the numbers or the variables from ourselves. We focus on the numbers and then we put the variables back in, okay? Now this, my friends, 6x squared plus 15x minus 21, in this case is almost our quotient. All right, so we don't want to color this in green yet because it's not our quotient yet. But I want us to go ahead and divide this by 3. Okay. Here's why I want us to divide this by 3. This 3 is because this was a 3. 3x minus 2. 3. If that number is 1, we don't need to worry about it. But if that number is not 1, we have to worry about it. So this 3 represents the leading coefficient of divising. Once we divide these, that will give us our actual quotient, right? So take a moment, 6x squared plus 15x minus 21, and I want you to divide and tell me what you get. That will lead us to our quotient. All right. So let's take this term by term. 6x squared, I want to divide that by 3. I get 2x squared. All right, now let's move to the next term. 15x divided by 3 plus 5x. And our last term, negative 21 divided by 3 gives me minus 7. So this would be our quotient. And we already have our remainder from up here. All right. So now we've answered the entire question. We said, no, it's not a factor, and we've specified the quotient and the remainder. All right. All right. So then I know this is a pretty complicated problem. Let's kind of work through some more simple problems to like get used to what we're doing here. All right. And then once we are done with those, we'll go ahead and take a break and then come back and take a look at 3.6. All right. So let's take a look at example 5, right? Is x minus 3 a factor of 5x squared minus 3x minus 36? All right, if it is a factor, indicate the factorization. If it is not, specify the quotient and the remainder. So because we're practicing division, specifically synthetic division, we need to think about what goes inside here. Then we need to think about what numbers to write here. We also know we're going to skip a line and draw a line. Right? What do we think is going to go in this little red box over here? All right, 3. Well, let's see. X minus 3 equals 0. X equals 3. Yeah, so once we set that factor equal to 0 and we find what x is, that number goes inside that little square. What numbers would I write in the yellow blob? Yeah, exactly. We're going to go back into our dividend. We're going to grab just the coefficients and see 5, negative 3, negative 36. All right, so let's walk through this process. First thing I'm going to do, I'm going to go ahead and bring this 5 down. Get a 5. I'm going to take the 3 and the 5, I'm going to multiply them, and I'm going to write that number here. 3 times 5 is 15. I'm going to combine the negative 3 and the 15 by adding them, and I'm going to get 12. I'm going to take the 3 times the 12. I'm going to write that number here. 3 times 12 gives me 36. Negative 36, and I have a positive 36. I'm going to combine those by adding them, and I get a 0. Someone tell me, what does that 0 mean? Okay, it means we have no remainder. It means we have a remainder of 0. All right. And that does mean that x minus 3 is a factor. All right. So since remainder equals 0, x minus 3 is a factor of 5x squared minus 3x minus 36. Okay. Now that answers the first question. Is it a factor? Yes. Yes, it is. Which means now we have to answer that second part. If it is a factor, indicate the factorization. Here's what I mean by that. 5x squared minus 36, or minus 3x minus 36 is equal to x minus 3 times something else, like a linear factorization. What is that something else? That 12 stands for a constant, right? That 5 stands for a linear term. That means it's not just like a 5 and a 12, but in fact, it's secretly a 5x plus a 12. So that bottom line actually gives you your quotient. Now, let me zoom back in for a moment. Up here for number 4, I said this was our almost quotient. Like I said, 6, 15, and negative 24 was our almost quotient. How come this time in example 5, I'm telling you this is the quotient? How come it's not an almost quotient?
Because there was no number in front of the x, so there wasn't anything you needed to divide by.
Yeah, and there is a number, right? That leading coefficient of the divisor. But if we go back in here, and math is full of so many sort of like secret, hidden, invisible numbers, you might notice that's a 1. And if we divided 5x plus 12 by 1, we would still get 5x plus 12. Okay, so sometimes we do have to do that extra step, and it's only when that number is not 1 that it actually changes our answer. Okay, this is our factorization. So now we have answered both parts of the question. All right, we said, yes, it is a factor, and more specifically, x minus 3 times 5x plus 12 is its factorization. Right? All right, let's go ahead and take a look at example 6 right here. Okay, so example number 6, is x minus 2 a factor of x cubed plus x minus 10? If it is, indicate the factorization. If it is not a factor, specify the quotient and remainder. All right, so I'm going to set up my little half square right here. What number is going to go inside that little half square? Yeah, that's going to be a 2. Good. And what do I put for the coefficients of that dividend? Ooh, 1, 0, 1, negative 10. Okay. I can imagine a lot of us sitting there being like, where'd that 0 come from? Right? If we just looked at our dividend, we might see a 1, and a negative 10. Can someone explain why we might need that 0 there?
I think in standard form for a degree of 3, you kind of assume that there's an ax to the 2 between it. But since it's not there, we can assume that the a is 0.
Good, good. All right. So let me just write here what would be the wrong setup. Okay, so if all you did was look right here and you said, I see a 1, and a negative 10, and you did this, this would be the wrong setup. Okay, so it's not what we want to do. Rather, what we do want to have happen is we want to keep placeholders, right? So like Ian said in this chat, there's no x squared. So this 1 is for the x cubed. I need a 0 for the no x squared. I need a 1 for the linear, and then the negative 10 for the constant. Oops. Right, so that placeholder there is super, super important. We want to make sure that placeholder is there. Now that we have it, we can go right through that same process of synthetic division. Okay, so we're going to drop the 1. 2 times 1 gives me 2. 0 plus 2 gives me 2. 2 times 2 is 4. 1 plus 4 is 5. 2 times 5 is 10. Negative 10 plus 10 is 0. I believe we have answered the first question. Factor or not? Yeah, x minus 2 is a factor of x cubed plus x minus 10. Beautiful. All right, and it's because that remainder is 0. Well, if it is a factor, then we need to say, indicate the factorization. So we could say that x cubed plus x minus 10 equals, what does it equal? What's a way that we can write that factorization? So we're going to take our divisor, x minus 2, and we're going to multiply it. This is our divisor, we're going to multiply it by our quotient. And where do we get that quotient? From the coefficients on the bottom. So we get 1x squared plus 2x plus 5. Okay. This is my factorization. Is this a linear factorization? Okay. Oops. This is a factorization. This is linear, but this one is quadratic. Since it's quadratic, we can't say specifically it's a linear factorization, but we can say it is a factorization. Okay. So a little bit of some process, a lot of vocabulary, hopefully some color coding to make that a little bit easier, and highlighting some of those common mistakes. All right. I'm going to leave example 7 to be one that you try on your own. I think if you're looking for some extra practice, example 7 is a great one to do for some extra practice. All right. But we're going to have a chance to practice our division in 3.6 as well. All right, so I want to kind of like leave what we have here. We'll take a break, we'll be able to come back and then think about how we tie together all the different pieces of this story that you've been learning this week. Okay, so right now it is 10:41, so let's take a break until 55. All right, so we'll be back here in just under 15 minutes, and then we will take a look at 3.6. Okay, so I'll see you folks back here and have a good break.